video, we're going to be talking about equations of lines, more specifically two types, one called the slope-intercept form, and then later on we'll be talking about what's called point-slope form. So first, let's talk about slope-intercept form. It's called slope-intercept form because in the equation we use the slope and the y-intercept, so we have a slope and an intercept. The y and the x variables here are going to stay as letters. They're going to represent any coordinate pair or any point on that line. So we'll be substituting values into the m spot for slope and the b spot for the y-intercept value. Let's practice writing it. Given a slope of -2 and a y-intercept located at 0, 8, we can write the equation in slope-intercept form by substituting the -2 into the m spot. So we're going to write y equals -2. Keep that x as a variable, and the y value of our y-intercept is 8, so we're going to say plus 8. Similar, on the next example, we got our slope and our y-intercept coordinate. We're going to substitute both into our y equals mx plus b form. We say y equals our slope, 2/3 times x, and our y-intercept is -3, so we could say plus -3. More commonly, though, you'll see it written as -3. Next, let's work backwards from there. If we know the equation, can we graph the line? So given the equation of this line, let's make sure we can interpret the equation. We have a slope of -4. That's always found in front of our x. You could write that as -4 or -4 over 1. Any whole number as a slope value always has a denominator of 1. Our y-intercept is going to be 0, 6. So we can start with that y-intercept on our graph. We can plot a point at 0, 6, or just 6 on the y-axis. And we can use our slope to get to other points on the line. So -4 over 1 means that I'm going to go down 4, right 1. So from here, count down 4 spots and right 1, plot another point. Do that again from that point. Down 4 more spots, right 1, and then again, down 4 spots, right 1. Typically, it's always a good idea to plot at least 3 or 4 points so you can get a good idea of what the graph looks like. If you run out of room, either going down or going up, you can count your slope backwards. So let's say, for instance, if I was at this point and I wanted to work backwards towards this point, notice that I'm just going left 1, up 4, the reverse of what I did previously. Over in the next example, identify your slope. Right in front of the x variable there is 1/2. So we're going to go up 1, right 2 between our points. Our y-intercept is at -3, so using the coordinate 0, -3 for a location, we can plot our first point on the y-axis there and count up 1, right 2 to plot a new point. Again, up 1, right 2, and up 1, right 2. There we have a pretty good idea of what our graph is doing and what it's doing as it crosses our axes. That's always a good idea to have. So there's how we graph slope-intercept form. Again, let's go backwards from that even, and let's try using a line to write the equation. So given this line on a coordinate plane, first thing you always want to find is a slope. We're going to need a slope, and we're going to need a y-intercept in order to write it in slope-intercept form. To find a slope, we need 2 points. If you're using a already drawn line and a grid that is evenly spaced, then you can go ahead and just count the change in y and the change in x. That would be one way to do it. This line is kind of easy because it's just going down 1, right 1. However, if you wanted to use 2 other points, you could. For instance, I chose to use these 2 points that are on the axes because one of their coordinates is 0, and that makes finding their slope, the math involved, a little bit easier if I'm using 0 values. But really, you could use any 2 points on this line and get the exact same answer for your slope. So using the slope formula, I could subtract my y-coordinates, -4 minus 0, and get -4. That's my change in y. It's going down 4. And then subtract the x values below that. So 0 minus -4 turns into 0 plus 4. So that equals 4. And then reduce our ratio anytime we can. So we have -4 over 4, which reduces to -1. So again, saying we're going down 1, right 1. The y-intercept was one of the points that I used at 0, -4. So we know the y value there is -4. So we can write our equation now that we have the slope and the y value. We're going to write y equals -x, or -1x would also work, minus 4. That would be the equation that graphs this line. There are a couple special case scenarios in dealing with equations of lines. We have horizontal lines and we have vertical lines. There are 2 acronyms that may help you in determining all of the possible properties of those lines, or really answering any equation that involves these 2 types of lines. That acronym is HOI-VUX. HOI is going to represent everything horizontal, and VUX is going to represent everything we need to know about our vertical lines. So the H in our HOI is going to remind us that we have a horizontal line. This O, which we can kind of think about as a 0, is going to tell us that we have a 0 slope on a horizontal line. And the Y piece of our acronym is reminding us that we write equations of horizontal lines by using a Y equals number. That number is actually the same as the y-intercept. So if you have y equals 6, we know our y-intercept is going to be at 0, 6. Really, any point on this line is going to have a y value of 6. So that's why we can represent it by just using this simplified equation, saying that all values, or all points, are going to have a y value of 6, which is going to create a horizontal line. Over here on the vertical side, V is going to remind us that we're dealing with a vertical line. U is going to remind us that a vertical line has an undefined slope. And X is going to remind us of how we write the equation for a vertical line. It's going to be x equals whatever the x-intercept is. And really, any point on that vertical line has an x value or an x-coordinate of -3. All right, so that was slope-intercept form. Let's switch gears a little bit and talk about point-slope form, which is just a different variation, different way that we can write a line. The point-slope form could come up with, could be derived, I guess is one way to say it. It could come from the slope formula. So one way that we can look at it is if we use our slope formula, and if we multiply both sides by the denominator, or multiply both sides by x2 minus x1, then that moves it over to here. So we have m times x squared, or x sub 2 minus x sub 1, not squared, which is what we have right here on the right side of our point-slope form. And then the leftovers over here after the denominator got canceled, just left over y2 minus y1. And so in point-slope form, we're going to take those x1 and y1 values, and those are going to be the coordinate values for any point on the line. M is still going to represent our slope, and it's still going to be in front of our x values. But these x and y's, those y2 and x2's, we're going to keep them as variables because we want them to represent any other point on the line. All right, so let's practice writing that equation, and let's practice interpreting it. So first we're going to interpret it. Given the equation in point-slope form, can we identify the point and the slope? So in that m spot right in front of our x's is our slope. The slope of this line is 2 over 3. And the point being told to us in this equation is the x1 value. So it says x minus whatever the x1 value is. So if it's 1, put a 1 there. And over here, the y value of that coordinate is going to be y minus whatever the value is. So y minus 3 means that 3 is going to be our value. It's a little confusing. Don't include that negative or subtraction sign and make it a negative value corresponding to your coordinate. that subtraction symbol is always going to be there in our most basic form. So we're just looking at the values that come next. Another way to look at this is, at least in my head, when I see something in point slope form, I'm thinking that my my coordinate is going to be the opposite of what I see. So if I see x minus 1 here, I got to think the opposite, and my x coordinate is going to be positive 1. Or here, if I see y minus 3, I want to think the opposite. So I'm going to write a positive 3 for the y coordinate. And that's going to help us when we see this next example. Notice that this time we have a plus in front of one of our coordinates. So where the heck did that come from? Because the formula says we need to use subtraction. So let's back up a step. This plus 3 is actually coming from the form where it's written as x minus negative 3. And so those double negatives right there are going to simplify to become a positive. So you could think backwards one step and put it in that subtraction form and see that the x value is going to be negative 3 and that the y value is going to be positive 2. Or in looking at it in this form, think the opposite of what you see. So you have x plus 3, so you know your x coordinate is negative 3. And here you have y minus 2, so you can think that your y coordinate is positive 2. So there's the point on the graph, and we look for our slope. It's right in front of our x, it's negative 4. So the power with point slope form is that we no longer need a y-intercept to write an equation. We just need any point on the line to write an equation. And so sometimes we do see lines or graphs that aren't showing that they cross the y-axis with what we can see. And so we still need to be able to write an equation of that line without knowing what the y-intercept is. And the cool thing about this is that we can actually take this form and we can rewrite it or transfer it into slope-intercept form, and we'll have the slope-intercept in that way. So we're going to do that next. Start off by writing an equation in point slope form. So given point A at negative 3, 2, given its slope is equal to 2, well, given a point and a slope, we can write the equation of the line. We're going to write y minus whatever the y value is, so y minus 2 equals our slope value, which is 2. And then in parentheses, the quantity x minus whatever our x value is, so x minus negative 3. Here we have that double negative example, and we're going to simplify that to make it plus 3 here in our simplified form. So final form is y minus 2 equals 2 times the quantity of x plus 3. From there, we can actually rewrite it in slope-intercept form, and we'll know what the y-intercept is. So in order to do that, we're going to solve for y. First, on the right side, we're going to distribute. So 2 times x is 2x, and 2 times positive 3 is positive 6. So we have y minus 2 equals 2x plus 6 so far. One more step to go to get it into slope-intercept form. We're going to add 2 to both sides, making sure that we add it to its like term over here, add it to the y-intercept. So now we have y equals 2x plus 8. We know our y-intercept is now at 0, 8. One more time, you can try this example, pause the video. We're going to start with our point slope form, given the point A is at 4, negative 2, and knowing the slope of this line is negative 1 to 2. Let's write y minus our y value, so y minus negative 2 equals our slope, negative 1/2, and then times the quantity x minus whatever the x value is, so x minus 4. Simplifying any double negatives gives us our final result. Y plus 2 equals negative 1/2 times the quantity x minus 4. So there's the equation of our line given that point and that slope. Let's rewrite it in slope-intercept form and figure out what the y-intercept is. Again, distributing it on the right, negative 1/2 times x is negative 1/2 x. Negative 1/2 times negative 4 is positive 2. One way you can think about that is what's half of 4? That's 2, and a negative times a negative is positive, so we got positive 2 here. One more step, get rid of that positive 2, move it over to the other side by making it negative, which is going to cancel this positive 2. So now we're left with y equals negative 1/2 x. You could put plus 0 there if you need to, but usually it's not written there, and it's implied that your y-intercept is 0. or the origin of our coordinate plane. A couple more examples just to step it up to one more level here. We were given the slope in those previous examples. In these two next examples, we're given 2 points, and we're asked to write the equation in point-slope form. In order to write the equation in point-slope form, we need a point. Well, we have 2 of them. We're covered there. And we need a slope. Well, in order to find the slope, we can use our slope equation to find the slope between 2 points. So let's find the slope. Let's subtract our y values on top. 1 minus 3 gives us negative 2 for our change in y, down 2. And our difference in our x's, 6 minus 3, gives us our change of x of 3. So we're going to go down 2, right 3, and we have a slope of negative 2/3. Next, we're going to choose a point. We need a point and a slope to write the equation. We have 2 of them. You're allowed to choose which one. So if we choose w as the point we're going to use, we're going to be able to come up with one equation. But you can also choose point P and come up with a second equation. Those 2 equations are going to represent the exact same line, just 2 different equations to represent it. If I choose point W, I'm going to say y minus my y value, so y minus 3 equals my slope, negative 2/3, times the quantity x minus whatever the x value of our coordinate is, so x minus 3 again. So there's our equation choosing point W. If I chose point P, I would have y minus 1 equals our slope, negative 2/3, times the quantity x minus our x value of 6 there. It's written a little small there, but there it is. The cool thing about this is if you solve both of these equations for y, or in other words, if you put these equations in slope-intercept form, you'll get the exact same answer. Because, of course, these are the exact same line, just 2 interpretations of it. One more time doing the exact same thing. Feel free to pause the video and try it on your own. Given 2 points, we want to write the equation in point-slope form. We're going to find the slope between the 2 points first. So negative 2 minus 2, that gives us negative 4 for our change of y, down 4. And then difference in our x values, 5 minus negative 1, that turns into 5 plus 1 and becomes 6. So negative 4 over 6 is a ratio that we can reduce if we divide both top and bottom by 2. We get negative 2 over 3. So there's our slope. I can choose either point to use and write it in point-slope form. If I choose point E, then I'm going to write y minus my y value, y minus 2, equals my slope, negative 2 over 3, times the quantity x minus our x value, so x minus negative 1. There's an additional step required right there to simplify that double negative and make an addition. So our final answer, y minus 2, equals negative 2/3 times the quantity x plus 1. There's a representation of our line using point E. If I chose point R, I could say y minus negative 2, which turns into y plus 2, equals our slope, negative 2 over 3, times the quantity x minus our x value, or 5, so x minus 5 there. Again, if you solve each of those equations for y, put it into slope-intercept form, you should get the exact same answer because they should be the exact same line. So there was a video on point-slope form and slope-intercept form. Practice using those equations. We're going to need them next time in class.